All right. Sorry, this is not live, but thank you for being here. And I hope you get a lot out of this presentation. And yeah, I guess I'll get started here. I'm going to be presenting with, I'm Jeremy Bartley, and I'm going to be presenting with Julie Powell. I am my background's in geography. I'm currently the program manager for ArcGIS Online and the JavaScript API. And I'm here with Julie. She is a product manager on the JavaScript API team. Now, Julie's going to be quiet for a little bit, but then she'll come back in the middle and towards the end of the presentation. All right, well, go ahead and get started. This is working with feature layers in the ArcGIS API for JavaScript. The agenda for today, we're going to talk about bringing in your data, rendering it, labeling it, querying it, and building an interactive experience. Before we get too deep into it, I wanted to spend a little bit of time talking about the background of the feature layer. For most of this presentation, it'll be about the client-side feature layer, but I want to give you a little bit of a feel for how feature layers work within the ArcGIS platform. It's really a cooperative participation between the front end and the back end. So let's go through a few of those. First off, feature layers can be rendered in 2D or 3D. It's limited to one geometry type per layer. It has geometries and attributes on the client. An important note, which I'll demo here in a second, is that it loads only the attributes needed for rendering. And Julie will also be referring to this later on. A feature layer can be created from a feature service or client-side graphics, and it's used for editing. It works with your data as features. These aren't chopped up geometries or graphics. This actually brings down the feature. Updates. When you update the data that backs this feature layer, it's automatically available to the client. The feature layer enables a dynamic styling and other interactive workflows. Has support for client-side querying, filtering, and statistics. So it's pretty awesome because you can bring your data from the server, and I'll show you how we work to make that efficient. And then once it's in memory, you can work with it just like it's a regular database. Julie's going to be talking to you about that in her section. Performance can be similar to vector tiled layers. And dynamic feature layer powered by feature tiles. That's really what we're talking about here, the dynamic feature layer powered by feature tiles. Let's look at what that means. First off, ArcGIS is an online platform for sharing information, important information at scale. You've probably seen a lot of these maps, whether it was the fire season, the fires in Sonoma County, the current coronavirus, this Johns Hopkins dashboard, hurricane preparedness for city of Tampa, or something from the Centers for Medicare and Medicaid Services. Each one of these apps actually has gone viral. They've received many thousands of requests per second, and some of them have millions of concurrent users. So keys to efficient public sharing of data-driven maps and apps at scale include returning the data as tiles, both for raster tiles, vector tiles, but also dynamic feature tiles, which is really the heart of the presentation we're going to talk about. These are generated on the fly and automatically handle data updates. Application queries that are common to and identical across different users. So the JavaScript API tries to query the same tile no matter what application it's in. And then we see response caching of shareable responses. So the server does its own response caching, and the CDN does its caching at the edge. I'll show this in a second. And then once it's on the client, you have the ability to take full advantage of client-side queries and analytics on the retrieved data. It helps applications leverage the power of the cores on users' devices. And we'll just do just a little bit of drill down into the feature tiles. This is an efficient, flexible, and scalable way to bring data to the client. So I got this example here. These are all the building footprints in New York City. I see there's 940,000+ polygons drawn on the view. Well, how did the data get here? Well, we queried for the data one tile at a time. Now this is something the JavaScript API FeatureLayer does for you automatically behind the scenes. If I look at this where my text box is, you'll notice I've just got a few features here. And so in this case, this is the default tile size, 512 by 512. The API is querying an envelope based on that 512 by 512 pixel size. We'll notice down here that it's a quarter the size. And that's because, as you can see below here, there's too many features that can be retrieved in one tile. So the feature layer works cooperatively with the feature service. So it requests as much data as it can get on a single query. Now you probably all know that feature services or layers and map services have limits on the number of records that can come back into a query. So what the API does is it tries to get it in one big tile. If that tile, if the service says you can't get all the data in this large 512 by 512 tile, then we subdivide and drill down deeper and request the next size of tile, and so on. In fact, in some cases, this data is so dense that I see that we've had to subdivide up to 3 times or 4 times even to get all of this data. Now, when the API requests the data, it's requesting for it in a certain way. I'm requesting for protocol buffer format. I'm requesting by this geometry, and I know that the geometry type is an envelope. We're telling the server to give us back 3 times the max record count. And we've only requested the fields that are needed, so construction year and object ID. I'll drill into this a little bit more in a second. And then finally, and we're also quantizing the data. So quantization is really a form of generalization. With quantization, we take and map all of the double precision coordinates to an integer grid. And what that means is that you might have a lot of points in a particular area, but if they're within the tolerance of this quantization, it'll all snap to the same point. And that's what this tolerance means here. What you'll note is that the API changes the tolerance as you zoom in. So it requests the next, it halves this. So it's instead of 38, it's something like 19 meters tolerance, and so on. And finally, it's telling the server that it's a tile request. The server gives back data over HTTP2 for ArcGIS Online. I see that the compression is Brotli. Brotli compression is similar to gzip compression, except it can compress a little bit more, and it's for numbers, and a lot more if you've got a lot of text in your attributes. I see this Xcache and Xfeature tiles. I'm going to talk more about that in a second. It's important to note that the data that we return from the feature tile query is highly efficient. So this is a JSON version of that protocol buffer response. And if I look down at the geometry here, I see that there are 4 points, 4 vertices for this ring. And it's the first point has the starting point, and then each point thereafter is just an offset. And this allows us to remove some of the digits of precision that we have here on every one of these points, and then just draw the line continuously. Once the data is on the client, we efficiently process it, triangulate it, and prepare those features to be drawn on the graphics card. Basically, everything that gets drawn on the GPU needs to be a triangle, and the API takes care of that for you. We do quite a bit of work to optimize the lines. We want to balance the display quality with overall performance. So if I look at this graph here, I've got memory requirements is on the y-axis and processing time on the x-axis. And if I look down at this first, this is the actual geometry. And we have a rule set. So if it's less than 2.5 pixels in width, we found that you cannot even tell we use this quad-based approach to triangulate. We ended up with 4 triangles, 8 vertices, and 12 indices. And it's fairly low in memory, and it's very low on processing time. And we notice that regardless of what your symbol type is, like regardless of what type of join you have, you can't see it and visually discern any difference between those join types. So we can get away with drawing this less detailed version. If it's more than that, based on the join type, a miter join is low on memory but has more processing. A bevel join has more processing and more memory, and then a round join has lots of processing and lots of memory. You can see all the triangles that need to be created in order to get this looking the way it needs to be. Now, we're not recommending that you change your symbols, but we just want to let you know that if we can render it faster with less memory without any visible artifacts, we'll do that for you under the hood. And so this leads to overall FeatureLayer performance over the last year. So in this example of 30,000 plus zip code polygons that are loading 32% faster, there's improvements to speed, accuracy, and the memory profile. We've improved how we triangulate the geometries, and we've improved how we generate those lines like I just showed you. So that's a pretty big increase over the last year. Now I'm going to jump back and show you a little bit more detail. Okay, I'm going to reload this page. I've got a feature layer here. It says the zip code polygons. In fact, I want to go to this page. Got my zip code polygon here. A couple things to note. I do not have editing enabled, but it is not shared with anybody, so it's private. Okay? We'll go back to this example, and let's reload this page. I'm using just the new map viewer right here. We see the queries got executed at the bottom. And see a lot of the same things that we showed before. I'm going to just reload one more time. There we go. What I want you to note here is that the sizes, 54 kilobytes, and the time, half a second basically for each one of these queries. This one took 1.24 seconds. Now this Xcache means whether or not it's coming from a CloudFront query, and this flag right here indicates whether or not it's being cached in the response cache of ArcGIS Online. I get trues for all of this, and I get relatively quick performance. Now let's go back to this page, go to the data, and make an edit. Notice that this last time that this data was edited was March 12th at 11:30. I'm just gonna make a slight edit here. Change it back so I don't forget. Now I see that the edit is 2:08 p.m. Now let's go back and refresh. Now this is going to take a little bit longer to do these queries. And we'll see that it's actually not going to be cached. So the map is drawn. I see misses from CloudFront. That's because this layer is not public. And I see no hits in Esri's response cache. The sizes are the same, but the times are much slower. 2 seconds, 4.5 seconds, 7.5 seconds, and so forth. If I look at this query, let me just pop this guy out for a second. If I look at this query, one of these guys here. There we go. So this is everything I just showed you before. And notice that the tolerance is this 1222. If I zoom in one, click, and I see new queries have come in, and the tolerance is now 611. So it's more detailed geometry. And we basically want no more than one vertex per pixel. Now I've still got this this token coming in here because this is private data. Let's make one more change to that service. I'm going to go dock it back to the bottom, and I'm going to go over here and make a change to the layer. I'm going to share it to everyone, and come back, reload this page. Now, anytime you make a change to the data or the schema, that response cache will be invalidated. Now I see loaded with the same feature tile request, but still misses on the CDN cache. Let's reload it one more time. Boom. Now I see all hits from the response cache. And look at the times. Way different. No longer half a second, but between 50 milliseconds and 100 milliseconds. And that's because this is coming from the edge. It's coming from the CDN. By default, every layer in ArcGIS Online has a 30-second cache setting that's public. So this 30-second setting means that both the browser and then also the server will never go back to the feature service to request the next set of data until that 30 seconds has expired. Now, if you are serving data that changes a lot, 30 seconds is a good time to keep it at. But if your data like this zip code data, which is not really going to change, we recommend that you move it up to 1 hour. Then it means that it's potentially 1 hour before someone is able to see the latest update data, but you'll get the best performance overall. Okay, I don't think there's anything else to show here, so let's go back to the presentation, sorry. Okay, and now I'd like to turn it over to Julie Powell and to talk to you about how to create these feature layers. Julie?
Thanks, Jeremy. Okay, let's talk about feature layer creation. So there's multiple ways in which you can create a feature layer depending on how you're going to hydrate that feature layer with your data. So one way is actually pointing to the feature service directly. Another way is if you want to point to an item that you've created in ArcGIS Online or ArcGIS Enterprise. And then finally, if you're working with client-side data source, you'll be using a feature collection. So let's dive into each one of those. So first, if you're creating a feature layer directly by pointing to that feature service REST endpoint, let's look at an example of that. So here's the REST endpoint, and as you can see, this particular feature service has some default drawing information. So this will be the render that actually gets loaded in the application and defines how it's going to draw my map. And then it has a bunch of attributes that I can work with. Now here's an application that uses that feature service. If I click on any of the features, it's going to show a very simple pop-up, and then it has that layer, the legend displayed. Or actually, this is the layer list. Okay, so let's have a look at my application. So first, I am defining a base map. This is using the human geography base map for the base layers, and then has a couple of reference layers on top of it. So then I define the pop-up template, and as you can see, I'm pulling out a couple attribute values for the title, and then defining the kind of content I want to display. In this case, I'm just showing like a field, like a table list of a couple fields, but you can put other things like media. If you have attachments, you can display that. So you can define everything you'd like inside the pop-up template. So then I simply create my feature layer, point it to the URL to that REST endpoint, point to the pop-up template. And in this case, I am setting a definition expression, and I don't want to display any features that don't have income information. This estimate total points to the income. And that's basically it. So as I mentioned, this particular service comes with drawing information, but in your app, you can override that if you'd like. So in this case, I've got this function called update render. Right now it's not doing anything, but if I uncomment this, what this is actually doing is it's cloning the render that comes with this feature service. And then I'm defining a new symbol. This map is using the firefly symbology, and I just picked a different firefly symbol that I want to display. It's just a different color. So then I go ahead and reassign that render to the layer, and then add it to the map as I was doing before. So if I save that and reload the application, now we'll see a very similar map, only it uses that other symbol that I had defined, so it's a different color. So this is actually updating the render in place, just one aspect of it. But you're not limited to that. Actually, you can go ahead and define a completely new render working with any of your attributes, for example, with visual variables. So in this case, I'm defining a color visual variable and a size visual variable. Both are based on the income data, and defining what colors I want to display, and then what size range I want to use. So if I then save that and then reload it, now we should see the same data but displayed in a completely different map using that new render. So it's pretty easy to work with, and then define the layer list. It's pretty easy to work with feature services directly, only you are going to be writing all the code to define exactly how you want it to display, how you want your pop-ups to work, and so on. Okay, let's move on to creating feature layers using a portal item. So this is when you create your map or your layer in ArcGIS Online or ArcGIS Enterprise, and then you load it using the item ID. So here we're looking at that same layer, only it was styled online with some different colors, and a pop-up was added. And to bring it into my application, I simply create the feature layer and then point to that same item ID. So here's that layer displayed. I can click on any of the features and then display a pop-up. And again, this pop-up was defined within ArcGIS Online. You won't see that anywhere in my code. And really, that's all you need to do. So, working with ArcGIS Online or ArcGIS Enterprise items really simplifies the code you have to write to bring in all that nice symbology and pop-ups and everything that you want to define in an authoring experience rather than writing that all directly in your JavaScript code. So in addition to pointing to that item within a feature layer directly, you could use the layer class and then do from portal item. So in this case, it actually doesn't even, you don't even have to specify which type of layer you're creating. It goes ahead and figures it out and creates the layers for you. So this could even point to a group layer, and then it'll create individual layers automatically behind the scenes. So you can also, rather than just pointing to just a layer, you can point to a web map. So in this case, I'm also going to define it by pointing to that web map ID. But you might still want to get access to that feature layer somewhere in your application, and if you want to do something with it. So the way that you do that, if you're first working with a web map, is you after the web map loads, you actually can go and use that find method and point to the layer's title. In this case, I'm pointing to this trees layer. So if you want to actually, work with the feature layer specifically for something, you can get it from the web map as well. All right, so the last way that I want to cover for creating a feature layer is by client-side graphics or using a feature collection. So the way that you'll do that is you'll set the source. So you'll basically be creating the array of graphics manually. You'll have to specify the schema. So in order for that feature layer to know how to display your features, it needs to know the name of the feature layer, the alias, the type of data it has, what type of geometry it has, and then the attribute definition. You also have to define object ID. That's a requirement. So what is the field that you'll use for the object ID that has to be unique? So let's look at an example of working with client-side features. So this is a really simple sample that you can find in the SDK. I can click on any one of these and it loads an image for that location. And these are EXIF images, so it does have the location data. So what this app is doing is basically going in, inspecting the image, finding the XY, and then adding it to the map. So let's look at how this works. So if you look at it at a very high level, basically these are all asynchronous tasks, which of course is why we're using the when and then. So first it loads all the images. You get promises from that images. You can create graphics from that. It creates the layer, and then it adds it to the map view. So let's dive into a couple of these. So first it's going to fetch the images and define where they're coming from, and then create a graphic for each one of those. So in the EXIF to graphic method, it's pulling out all the location data. It's defining the object ID. So then when I load it into a feature layer, it can have that unique identifier. And then here's the important part. Here it's creating the feature layer. It's defining what the object ID field is that we've created earlier. Of course, the source is being set to those graphics that's being created for each feature. And then it defines what are the fields that are part of this data source. It's defining a popup template that's similar to what you saw earlier when I was just pointing to a URL, so that's the same. And then defining the render. So really it's pretty simple to work with client-side graphics. There's a lot of similarities when you're working with a URL directly or a feature service, only you have to define the schema of that layer and then the object ID field. And of course, create each of your graphics manually.
Okay, thanks, Julie. Let's talk about the visualization. So to render your layer, or to visualize it, or to create a style, you use what we call a renderer. A renderer defines how this feature layer is drawn. Has a simple renderer, class breaks renderer, unique value renderer. Those are all different types of renderers that you use on your layer. Let's drill into this through the guide here. I definitely recommend that you take a look at this guide, and it is a very nice way. Let me go ahead and zoom in so you can see, to get a feel for the different types of visualizations you can do. There are visualizations that are location only, and then there are visualizations that are thematic data-driven symbolization. You can use ArcGIS Online, the old map viewer, new map viewer, to author your visualization or your style and bring that into your app, like Julie showed you previously. Or you can manually construct your renderers in the code. So that would be to create a class breaks renderer, to set it on your layer and define all the breaks. Or you can use the smart mapping APIs in the SDK to be able to generate a visualization based on your data, so that you don't have to figure out exactly what it should be. Our tools will help you give you the best default that we can based on the data you have. Now, it's important to note you would never use these smart mapping APIs, on every app load. This is really to be used in a data exploration app or in an app that allows you to author simple maps. Okay. Let's go back to the top here. And just to drill through some of these, location style, visualize all features with the same symbol. You can scale the features based on real world coordinates. So in this case, these are tree canopies. You can scale also, these are all feature layer examples. You can scale 3D objects. So these are realistic trees from a 3D web style, and their height is driven by an attribute, their size is driven by an attribute, and the color is driven by another attribute. And color in this case is carbon storage. You can use rotation. You have the ability to visualize points in 3D. You can use heat maps, scale-dependent visualization. So as you zoom in, you switch from a heat map to show the actual data. You can visualize by type. So like what is this thing? What is this map? So freeway type, interstate, US highway, state highway. You can take your feature layer and extrude the building footprints based on real world heights. You can use Arcade to do custom, come up with new data based on your existing data to then visualize, like this example that creates this predominance visualization. Dot density is another renderer style that you can use. You can visualize with class breaks if you want to break the data up. Do continuous color, continuous size. You can also extrude features based on some value. And using opacity to change the strength of some feature. You can also combine these two together, like this thematic multivariate visualization, in 2D or 3D. Okay. So let's go through a couple of examples here. So we got this simple renderer here, and it's of counties in France. I'm going to open up the source code and just show you what this code looks like. So created my feature layer. I'm setting my renderer. It's a simple renderer, simple fills, and I'm giving it this tomato color. I'm saying there's no outline. I'm giving the outline with a 0.5 pixel width and making it a white semi-transparent color. Okay. Let's do this next one. This one with visual variables. Open to my internet here. There we go. And I see that this color is a continuous color. It's going, the lightest color here is 17,000 euros, and the darkest color is 28,000 euros. And then in between, it is interpolating. Let's look at the source of this guy. Zoom in. And we see the difference. So I've still got this simple renderer, but I'm not going to give it any color. Because color is going to come from this visual variable. With this visual variable, it's of type color. I'm using an attribute here, this value expression. This could be an arcade expression. Or if I was just doing field, I could also specify the field, and that would be that field. And what this expression does is every time this gets executed, it's going to return the feature's value. So let's say it returns a value of 1700. Well, there are two stops here, 17,000 and 28,000. So if it returns the 17,001, it's going to give the color white, and it's going to specify this label using the INTL. And if I specify 28,000, it's going to give the color red. And then anywhere in between, it's going to interpolate between white and red. Make sense? Now, let's do this through the Smart Mapping API. Now, this is actually going to take a little bit longer because, like I said, the Smart Mapping API is going to look at the actual data and then recommend a style or renderer that you set on your data. So We see here I'm just mapping median income, and I'm using above and below the average in this case. So let's look at the source. And so I've got my feature layer created. My color renderer, I'm going to go create continuous renderer. And this function takes the layer, the field I'm looking at, and the theme I'm trying to do, which is above and below. So that's above and below the average. And then we're going to optimize the outline so that as you zoom out, it's a thin line, and as you zoom in, it's a thick line. And all I need to do is pass it the view. Once that's done, it's going to give me back a renderer that I can just set on the layer. Now, like I said before, you don't want to do this on every app load because you noticed how slow that was. That's because it's pulling the data down to the client, and then it's analyzing the data to come up with pulling out the summary statistics, looking at the average feature size in some cases, and producing a renderer based on that information. Where you would want to use this would be in an app. Let's say you wanted to build a simple map authoring app that let people add any layer, and then they could visualize it by color or size. You could call these functions, it would generate that renderer, and you'd set it. And then if you saved it into the web map, then anybody else who opened the map would have that actual renderer. Let me see. Yeah, just want to check one thing here. No, okay. Let's switch this back, drop out of this, and look at the smart mapping sliders. So once that feature layer is rendered, I can also use the smart mapping sliders to change. Now what I'm doing here is I'm changing those stop values and the colors. So let's look at the source. And it used the same smart mapping function. It also generated a histogram for that layer. Then it created the color slider from renderer result, so from the renderer and the histogram result. And then I could add that slider widget to the view. And finally, on thumb change, then I can clone the renderer, change the visual variable, and set it back. Pretty cool. Finally, one last one. This is from a portal. So really, just let's look at the source. Now in this case, this is coming from that layer in the portal. The renderer is coming, the whole layer is, just like Julie showed you before. So this is a great way to predefine what you want your layer to look like, including how you want it to behave, like through pop-ups, and to bring that directly into your app later with very little code.
All right, so now I'd like to move on to labeling. So labeling with feature layers, because you're working with all the features client side, labeling also happens on the client. And now I'm going to show a range of examples where we start with very, very, very simple labeling all the way to how you might want to style your labels for 3D. So in the first case, this is the most simple case that I have. I'm just displaying the temperature for each of these locations. So if we have a look at the code, labels are defined using a label class. So here I've defined that I want my label to display the below right location, and then I'm using our arcade expression to get the temperature from each feature. And then I can define the style of each label. So that means like the font that I want to use, the weight of that font, the color, halo, and any other properties you want to define for the labels. In a little bit more sophisticated example, now I'm displaying two different label classes, and I'm using a where expression. So I'm using this label class when the temperature is less than or equal to 32 degrees. That's the blue label class. Then I'm using the red one when the temperature is greater than 32 degrees. So you can basically set any sort of where clause determining when you want to display that particular label class. So then down here, the feature layer definition, in the labeling info, I'm saying, okay, I want to use both the low temp class and the high temp class, and then each one of these will determine when they display based on that where expression. But you're not limited to display only one at once, one labeling class at once. You can have multiple labeling class to use so that you can display multiple labels for each feature. So in this case, not only are we displaying the temperature, but also the humidity and then the station name. So let's have a look at how you do that. So this is the same code as before for the low temp and the high temp class. And again, they only display based on what the temperature is, one or the other. And then the humidity is always displayed. There's no where expression. But notice that the label placement is the below left. So it's displayed at a different location than the temperature. And then also display the station name at the below right. And then again, in the feature layer, I'm just specifying all these labeling class for each feature. Now, this looks okay at this scale, but if we zoom out, we might not want to display so many labels, such detailed information at that zoomed out level. So in this case, when I zoom in, I want to see all the labels, and then I zoom out, I only see just the temperature of each station. And this is really handy. So the way that this is done is actually determining for the humidity class what the min scale is. So I can define what I want that min scale to be and then not display it as I zoom out. And again, when you actually define it in the feature service, you're still adding all those classes, but each label class kind of determines when it should be displayed. So this one's not displaying based on scale. Okay, so now this has all been 2D. Let's think about how you would do this in a 3D scenario. So you can define it in the same exact way that you did in 2D. So this is actually just using that same low temp class and high temp class as before, creating that same text symbol as before, and this is basically how it's displayed. Now the list looks okay, but what I've done just for the effect is actually turned off elevation, because you may not always be using elevation. But if we turn that back on, what you'll see is the labels don't always display well. So I'm going to go ahead and reload that now that I turned back on the elevation. And you might actually get labels that are blocked by, whether it's a mountain or a building. They might be hidden inside a valley. So, and if we kind of zoom out, you might see some more, temperatures that will be hidden. So what you can do for that is use some things that are specific to 3D. So what I've defined in this same application is a whole other style for the 3D case, which I've used in this method, or symbol, sorry, I've defined a different symbol for the create 3D symbol. So rather than creating the 2D text symbol, here, I'm actually going to define a vertical offset. So that means it's not going to display straight on the ground. It's going to be offset vertically and then have a call out. So that's like the line that displays above to kind of connect that label to what feature it's pointing to. So here, I'm going to go ahead and both classes specify that I want to use that 3D symbol for the label. And then save that and then reload it. And your labels will display a lot nicer, taking into account that you're going to have 3D objects and things like elevation to account for. So it displays a lot better. Okay, now I'd like to move on to querying. So if you'd like to query for features from your data source and bring them into your application, there's a variety of ways you can set up the criteria. You can do an attribute query where you're using a SQL where clause, do spatial queries where you're passing in a geometry. You can even indicate the type of geometric operation you'd like whether it should intersect or contain. And then you can do statistical queries. And you can do actually any combination of these three things. So let's look at a basic example. This is a sample in the SDK that you can find. What it's doing is basically I click on a point and then it finds all the features that intersect with that point and are within half a mile of that point. So let's have a look at the code. So first I'm just creating the feature layer by pointing to a portal item. And then when I'm actually ready to do the query, it's sending in the point that I clicked on for the geometry. The distance is going to be a half mile, and for units, that'll be miles. It's going to, all features have to intersect, so that means it doesn't need to be fully contained. I'm not returning the geometry. And then this is something that's fairly new within the last year is return the query geometry. So in this case, since I'm interested in actually drawing the full buffer around the point that I'm using for the query, I want to return that geometry that was used to calculate the query so that I can then display it on the map. And then I'm saying I want to return all of the attributes. You can specify any set of attributes you want to be returned in the query. And then once I get the results back, I can go ahead and add those graphics to the map. So it's fairly straightforward. Now the query that I've covered so far is when you're querying against the layer. So that means you're actually going to the full data source, working against the full data set, performing the query, and returning the results. If you've specified that you wanted to return the geometries, you're getting the full resolution geometries back. Now I'd like to switch gears and talk about building an interactive experience using a variety of capabilities that we have available in the API. Now, first off, you can query, rather than going to the server each time, you can, instead of querying the layer, you query the layer view. So you actually performing the full query client side. And this results in very, very fast queries. I mean, it really just seems instantaneous because you're not doing that full round trip to the server to get results. You're actually working with everything on the client. But there is some limitations to be aware of and some programming patterns that are important for me to point out. First of all, it only works with the available features that are in the browser. So if you just have a subset of the features that are available on the client, you won't be querying the full data set. Also, we generalize geometries for performance. For example, if you have a very detailed geometry and you have multiple vertices that really you would not be able to see with your eye in the screen, we simplify them to be able to work with less data and display faster. So the actual geometries on the client are simplified and you wouldn't have the full resolution geometry. So something like an editing application, you probably wouldn't want to edit just your geometries client side. And so actually the editing widget, when you click on a feature, it goes and pulls down the full resolution geometry so you can edit the actual vertices. So there's certain scenarios where you want to make sure you're actually working with the full geometry. And then also, as Jeremy talked about earlier, you have to make sure that whatever you want to query client side, that you've already configured as part of your layer to be one of the attributes that's pulling down when it's loading the data. All right, let's look at a couple of examples. So this is that same example that we were looking at earlier from the SDK, only I've updated it to do a client-side query instead. So all the code is very, very similar. There's only a few different things that I'd like to point out. Now, first of all, rather than going ahead and query as soon as someone clicks on the map, what I want to do is make sure that the layer view is finished creating. So what I can do is view.whenLayerView. So if I do that, then turn on the click handler, basically I know that it's going to wait to query after the layer view is ready. So I've got the click handler on, and then here, when I'm actually going to query the features, notice that I'm doing layerView.queryFeatures as opposed to layer.queryFeatures. So layer view, when you're working against the layer view, that means you're working client side. Really, all the rest of the code is the same. So you perform the same sort of query, same type of query criteria, and then you still add the features to the map. So if I then click on the map, then you see the results just like you did before. But really, you can't really see the benefit of working client side in an example like this because really you saw a very, very similar experience when I was going to the server because it's just doing a very simple query. In this application, I'm showcasing some of the things you can do client side. So rather than having to click on a location on your map, I'm actually hovering and performing the query as I hover. And this is really something that you couldn't do well if you're going to the server each time you want to perform the query. So let's have a look at the code. So again, everything's very, very similar as before, but there's a few things that I'd like to point out. First of all, of course, I'm not listening for the click event. I'm looking for the pointer move and pointer down so they can execute on hover. So I'm querying features when that happens. And then also, I want to point out the watchUtils.when false once. This is a really important method because basically it's waiting for the layer view to be done updating. In other words, the layer view has loaded all of its data. It's ready to be queried against. So that's something to be aware of if you're building client-side applications. Coming down here, the code again is very, very similar. Should look familiar like the previous example where I'm querying against the layer view. So it's performing client-side. But there's something else that you may not have seen before, which is these promiseutils.debounce. This is really important when you're executing the asynchronous call within a synchronous flow. So what this promiseutils.debounce does is if this method is called multiple times simultaneously, what debounce does is make sure that it's the first time it is called is finished executing before it's called again. So each time it's called over and over and over and over as I'm moving the mouse, it doesn't let it be executed over and over until each time it's fully completed. So it really does show a better performance by using these promiseutils.debounce. So it's definitely something to be aware of when you're building client-side applications. Okay, so that's querying. And now I would like to talk about filtering. So I'm sure you're familiar with filtering. Um, you've probably done it by setting a definition expression that's very similar on the layer. But this is actually, we're talking about a client-side filter. And the way you define a filter is by creating the feature filter. Feature filter is essentially very similar to a query where you're specifying the geometry and whether you want a distance um, with that, like the buffer that I was showing before. The attribute, is there a SQL where clause criteria you want to add to that filter? You can also indicate a time extent that you want to filter, and actually that's how some of the time demos that I'll be showing later are working. And then also you could use object IDs. So think about the scenario where you already know what features you want to filter out. Maybe you did some other query somewhere, but basically you already know those features and you could just pass in the object IDs of those features and bam, you can go ahead and filter on the client. So the filters applied again to the layer view because you are working fully client side. So let's have a look at an example. This is another example in SDK. And what this is doing is just filtering between, I think these are hurricanes, flash floods by season. And as I click on that, it's just doing the client side filter based on season. So if you have a look at the code, here looking for what you've actually clicked on, what season, and then the flood layer view, it's filtering on it, and then it's setting the attribute query where season is equal to the selected season. So it's pretty straightforward. But again, all happening client side. To take it a step further, I want to talk about a different kind of filtering. So in the previous examples, actually removing features from the map that don't meet the filter criteria. When we talk about filter and effects, it means we're still leaving the features that don't meet the criteria on the map, only we have a particular style to emphasize the features within our criteria, and we have another style to de-emphasize the features that don't meet our criteria. So let's have a look at an example of that. Now what we're looking at here is actually a web application template you can find in ArcGIS Online and ArcGIS Enterprise. And this is a custom widget view on top of the API's legend widget. And what it allows you to do is focus in on a particular fuel type that you're interested in. So if I select hydro, you can see those hydro power plants, but you also see the other types of power plants on the map. They weren't removed, but they were de-emphasized. And I think this is a great way to really provide the context around the things you want to emphasize. So then I can go ahead and select other types of power plants and interactively explore the map. So this is just another type of filtering option that you have available to you. It's called filter and effect. Now I'd like to show you another example that's working with time. So this particular demo is a pretty cool visualization of the expansion of trees planted in Berlin. So what's happening is the time slider down here, as it moves, it shows you all the trees planted in Berlin at that time frame, within the time frame. And everything that you see kind of a little bit with more opacity and a little bit more gray are the trees that were planted before the time slider focus point. So what that enables us to do is kind of see the cumulative growth of the trees throughout the city and then highlighting the trees that are planted within the particular time period of focus. So this example is actually using both filtering. So here I have the layer view.filter where the year planted happens after the right handle of the time slider. So it's actually removing anything from the map that happened beyond this time frame. And then in this case, layer view.effect, so it's actually defining a feature, a filter effect. Everything that happened before the focus time period, so everything before here, it's still on the map, only it's de-emphasized. So the way that's done is basically defining a feature filter. So here it's based on the time extent, so the time extent, and then the geometry, so everything that's within the view. And then everything that doesn't meet my filter, it's excluded, the excluded effect. So it's applying a grayscale and opacity. So you can see how in some circumstances, you might want to apply both a filter to the layer view and a filter effect. Another thing you might want to do when you're implementing interactivity is highlight features. So the way the highlight works is essentially you're on the layer view, you're calling highlight, and you're passing in either one graphic or an array of graphics or a single object ID or an array of object IDs. And then it returns a handle to that highlight so that later when you're done highlighting, you can remove it. You have the ability to just use the default color, which is cyan, or you can override that color, specify opacity, and even put in a halo effect and say the color of the halo and the opacity. So it's pretty configurable in terms of what you want the highlight to look like. So let's look at an example. This is using our new feature table widget. And in this application, what I can do is select a couple rows and then you see them highlighted on the screen. So if we have a look at the code, what's happening is I'm creating the feature table and then saying which specific fields I want to display. And then the feature table has an event called selection change. So when the selection changes, basically I'm figuring out which features should be highlighted and which features should be unhighlighted. So here I'm removing a highlight, and then over here I can do layer view.highlight and then pass in the feature that I want highlighted. And that's pretty much all that it takes to do the highlight. Yeah, the API is really powerful when it comes to all the client-side capabilities you could do. And that's because it actually has a full in-memory database that's running on the client where you could do any sort of query that you could do even to the server. So that's what makes the filtering and querying and statistics such powerful capabilities when you're doing client-side programming. But there are a few things that you really have to be aware of when you're doing client-side operations. So here's some things to be aware of that actually I have run into when I've been building demos. So first of all, remember that you're only working with features available for display. You aren't necessarily working with your full data set that you have your feature layer pointing to. So just be aware of that. Also, geometry is generalized, as I mentioned before. So for example, if you're doing something where you need the full resolution geometry, you can still do all your client-side querying and filtering and so forth. But then when you need that full geometry, you can simply do a server-side query to get the full geometry. And then something else that we also covered was before you start working with the layer, make sure it's been created. So you can do that using layer view.when. And then as we looked at before, if you're going to do some sort of query right when the app's loaded or doing some sort of statistics, you can make sure that all the data has been loaded by doing watch utils when false once and then using the layer views done updating. And then again, if you are making asynchronous calls within a synchronous code, basically making a lot of calls, even simultaneously, you might want to take advantage of the promise utils debounce function. So just some things to be aware of. As you can see throughout this section, the API is really powerful when it comes to all the client-side capabilities you can do. And really that's all because it is powered by an in-memory full database. So you can do any sort of query or filtering that you could do on the client as you could on the server. So when you're doing all of this client-side development, there are some things to be aware of. So for example, and all of these things I've already mentioned earlier, but just to summarize, remember that you're only working with the features available for display. So you can't be certain that you're working with your full data set. If you need to make sure you are, you need to go do the layer.query versus the layer view.query. And so go to the actual source. Also remember that geometry is generalized. So you can still build these client-side workflows, but then as soon as you need your full resolution geometry with all the vertices, what you can do is actually just perform a query and then get that geometry and do whatever you need to do. And actually that's what happens behind the scenes with editing. So during display with the feature layer, it displays all the generalized geometries, but then as soon as you click on something to edit, it actually pulls down the full geometry, and then you can edit the vertices as you need to. And then make sure the layer's been created before you start doing things with it. So, or actually the layer view. And the way to do that is the layer view.when. Also things that we looked at is if you're going to perform a query or statistics right when your application loads, you're going to want to make sure that the data is finished loading. So the way to do that is using the watch utils when false once, and then watch for the layer views updating to occur. And then finally, when you're making a lot of asynchronous calls within a synchronous code, so if you think you'll be executing a function, multiple times simultaneously, you can use the promiseutils.debounce function. All right, let's move on to editing. So editing is done with feature layers, and of course that's when you want to update features directly within the web browser. So the first thing you need to know is, can you edit the features? So first of all, the REST endpoint does indicate what is supported. And if you have a hosted service, you can check the settings for that hosted feature service to see if editing is allowed. So if you go to the settings tab and scroll down to the feature layer editing section, there's a whole bunch of settings you can see for editing. So for example, can you edit it at all? Then there's other things like who can edit it? Do you only want the person that created a feature to be able to edit it? There's a bunch of other settings you can do. So have a look at your service and you can configure what kind of editing you want against your feature layer. Now there's primarily two paths you might take for implementing editing with the API. If you want to implement the actual editing workflow manually and then simply post the changes to the feature service, you'll use apply edits. Alternatively, and the much easier way, is you're going to be using the API's out-of-box widgets. The editor widget is what is comprised of the full editing workflow, which is the editing of the attributes or geometry, and then you can actually save the changes to the feature layer. You can also use some of the widgets that make up the editor widget. For example, if you're just going to be editing attributes, you can use the feature form widget. I'd like to show you two very quick examples of editing using the editor widget. First, say I want to add a feature. One thing I can do with the experience is search for a particular feature template. This is the list of feature templates. I can add it, and then it lets me, change the geometry. I can configure the attributes, and then add the feature. Alternatively, I can edit one of the existing features. It loads all of the attributes to edit, and then of course I can move it. So this is a very simple editing workflow. And if we look at the code, it's actually very minimal code. Essentially, I'm just creating the web map and the view and the map. and then creating the editor widget. The editor widget automatically detects the editable feature layers in the map and then automatically populates it in the editor widget. And of course, adding it to the UI. So if you just want all of the default behavior with the editor widget, there's quite a bit that you can do with very, very minimal code. But then, of course, you can do quite a bit of customization by configuring the editor widget. So in another example, here I've got some trails, and rather than just displaying the editor widget here, what I can do is launch into the editing workflow from the pop-up. So the way that this application implements that is via a custom action in the pop-up. So here I click on the custom action, and then it launches into the editing workflow. And here, and this is something that is new in version 4.15, I can actually add an attachment. So I'll select a file. Here's a picture of a beautiful lagoon near my house, and then add that. So there's quite a bit of flexibility with how you can implement editing with the various editing widgets with very minimal code, and it's all implemented against the feature layers. I'd like to close out by thanking you all for your amazing work, which is more important now than ever. And also invite you to watch all of the other sessions that we have made available that dive deeper into the various topics we touched on. For example, there's a session dedicated to editing, another one all about interactivity and working with time. So check out the other sessions we've got, and they all build on this session. Thank you very much.
Thanks, Julie. That was great. Thanks for being with us virtually this year, and next year hope to see you at the Dev Summit in person. Thanks.